All right, so today we are reviewing for our exam, right? That is on Tuesday. And I've got my camera set up in the back there. So I'm going to record. All the camera can see is what's on the board, so you can't see you, don't worry. All right. And what will happen is after class, later on today or maybe tomorrow, I'm going to upload these videos to YouTube. I will send everybody an email. That email will have a link to where to find the video, all right? Now, if y'all like it, I can continue to do it for the rest of the semester. We'll see. But I still want y'all to come to class. So that's like the one downside to it. So people will be like, oh, well, he's just going to record it. I won't go to class. So anyways, we'll see how it goes. But I wanted to at least get the review recorded that way because we have a lot to talk about. And that way you can pay attention and go back and watch a video over the weekend or whatever. I did send out a review, like a week or so ago? Did y'all get that through email? Check your Canvas email. But even if you didn't, I'm just going to go over what the test is going to be about, all right? So this exam is going to cover these topics. So the topics are going to be graphing or sketching, lines, quadratic functions, and polynomial functions. Those three things. Those are the three main ideas for this exam. So what I'm going to do right now is I'm going to start doing examples similar to the ones that I gave you on the review. I'm going to do different problems. I don't want to do those. That way you have more problems to practice. But let's get right down to it. Let's start with lines, then we'll get to quadratics, then we'll get to polynomials. Last class, we were studying rational functions. Those will not be on the exam. I told you all that last time, right? That will be for the next exam. So here's an example. Here's an example. Are you taking off just long enough to get us all sick? Thank you. No. Feel better. All right. So the first example, sketch the following. Negative 3x plus, let's go with 5y equals 40. Sketch this. So the first thing that you have to do when you see this is realize, what you're looking at, right? This is a linear equation with two variables. So you have to know that this is a line, right, just by looking. And then you have to pick which method you're going to use to do it. And I showed you all two different methods. One was called the intercept method, and the other one was called the slope-intercept method. So I'm going to show the intercept method. When I do it, maybe it'll ring a bell, all right? So if this is a line, right, if we know that this is a line, then all we need to do to sketch a line is have 2 points, right? I just need 2 points and I can draw the line. So to get the 2 points, the first thing I'm going to do is I'm going to find the x-intercept. And to find the x-intercept, what we do is we set something to 0. What do we set to 0? Y. We set y equal to 0. The opposite of what we're looking for. And so set y equal to 0 in the equation. And it basically kills off that 5, right? And all you're left with is negative 3x equals 40. And then you divide both sides by negative 3. Now, you may need to get a calculator out here. So what is 40 divided by negative 3? Negative 13.3. And I'm not going to care too much about how you round or anything like that. One decimal place is fine. Negative 13.3. That's your x-intercept. So right now, just as we're doing this, I'll just show you what we've done here is we have determined that this line hits the x-axis, right? The x-axis at negative 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is negative 1. Negative 13 is right here. Negative 13.3, you're going to put a dot somewhere around there. I'm also going to label this point. That is the point negative 13.3 comma 0. Because the x-coordinate, right, is negative 13.3, the y-coordinate is 0. So I have one of 2 points. I just need one more, right? One more point. So to get the other point, I'm going to find the y-intercept. And to do that, I set x to 0. Okay, if I set x to 0 there, I get negative 3 times 0 plus 5y equals 40. Kills off that negative 3. And we get 5y equals 40. Divide both sides by 5. 8. Y is 8. So that just means I go up 8 on my y-axis. 1, 2, 3, 4, 5, 6, 7, 8. There's 8. I put a dot. I label the point 0, 8. Right? The x-coordinate is 0. The y-coordinate is 8. And then I come in here with my straight line. Why did I put that in there? I come in here with a straight line, right? I connect these with a straight line, as straight as I can be with it. And yeah, that's not very straight, but it works. Okay, there you go. We're done. Okay? Any questions? Okay, let's do another one, all right? I'm going to do 2 of these, and then I'm going to move on. All right, so the next one I'm going to do, I'm going to put some fractions in here. So, because I think you all said you liked fractions. Yeah. Yes? And so I want to make you happy. Okay, so let's do this. How about 1/4 x minus 2/3 y equals 3? Let's make it 6, sorry. So the same instructions, sketch this, right? So first thing, we have to know that this is a linear equation in 2 variables. We have to know that this is a line. Do you all know that that's a line? Yes? Yeah. Okay. So we need 2 points. So should we do the same thing? Yeah. Yeah. X-intercept first. To do that, we set y equal to 0. So when we set y equal to 0, it's going to kill off the y, or that piece with the minus 2/3. I'm left with 1/4 x equals 6. And the reason I want to give you this with fractions is because I want to make sure you are comfortable in terms of solving for x here. How would you get x by itself there? There's kind of 2 ways to think about it. Divide by what? Divide 1/4 by 6. So you would divide both sides by 1/4, right? Yeah. That's one way to look at it. Another way is to multiply both sides by 4/1, by the reciprocal. So multiply both sides by 4. I prefer the second method because I think it's easier, but look, it's totally up to you. I'll show you both ways. So first way is to do this. Multiply by 4 here, right? Multiply by 4 here. Really, we're multiplying by 4/1. And then how do you multiply fractions straight across, right? What's 4/4? 4/4. 1, right? So that's just x, isn't it? I mean, that's the whole reason I multiply by 4. And then the right side, what's this? 24. 24. So x is 24. Because again, you're multiplying like across, straight across. The other method would be to divide both sides by 1/4. This goes away, we get x. This is the part I'm concerned about, just making sure you know what this means. This means 6 divide by 1/4, right? And then that you look at as keep. Remember, division, you keep it, you dot it, you flip it, right? Keep, dot, flip. And then that's the same thing as this, right? 24. So either way, you should be able to get x is 24 there. Or that way. I'll do the picture at the end. Let me get both the x and the y-intercept first. For the y-intercept, I set x to 0. And for that, I have 1/4. I plug in 0, it goes away. Minus 2/3 y equals 6. This goes away. I have negative 2/3 y equals 6. Yeah, this one's going to be a little weird. How many? Okay, so let's do a quick vote. How many of you like just multiply both sides by 4? How many of you like this way keep dot flip thing? Yeah, I'd say it's about, yeah. So if you like this way where I multiply by 4, then this is going to be a little tricky. What would you multiply both sides by here to get rid of this fraction?
Positive 3 over 2.
Close, not positive. You'll use the same exact thing. Since it's negative, you're going to want to multiply by negative 3 over 2 because two negatives will multiply to be positive. You see, if you use positive, it'll stay negative. Does that make sense? So if I do that way, I would have to multiply this side by negative 3 over 2 and then multiply this side by negative 3 over 2. And do y'all see that the 3's cancel, 2's cancel, two negatives become plus? So this would just leave you y. And then how do you multiply this? Straight across? What would you get over there on the right-hand side? What's this? Negative 18 over 2, and that's negative 9. Negative 9. That's one way. If you do it the other way, then you divide here by negative 2 over 3. You divide this by negative 2 over 3, right? That's what you'd have to do. These go away, become y. Over here, this is 6 divided by negative 2 over 3, which equals, now you do your keep dot flip again. Keep it, dot, flip it. I'll do 3 over negative 2 like that. And this, you'll get the same answer because if you rewrite the 6 as 6 over 1 and then multiply straight across, you should get 18 over negative 2, which will still give you negative 9. Do you have questions? Y'all are looking at me weird. Is this all right? Negative 9? All right, I'm ready to draw the line. So I have two intercepts. X is 24, right? I'm not even going to put tick marks. I'm just going to put here's 24. And the y is negative 9, which is somewhere down here. Like that. Now, I will want you to put these as points just so I know that you got them right. Negative 9. Oh, no, wrong, sorry. 0, negative 9. That's what I'm looking for. Questions at all? No? Can I proceed? What the hell's going on? Just make sure this is working. Yeah, okay. All right, next thing. Are these lines? So this is, I'm still talking about lines right now, okay? I'll let you know when we transition to quadratics. Are these lines parallel, perpendicular, or neither? Do y'all remember us talking about parallel lines and perpendicular? Okay. So I'm going to give you two lines. The first line, I'm going to call it L1, and here's what the line is. Negative 2x plus y equals 7. And line 2 is, let's go with x plus 2y equals negative 3. So I've given you two lines, right? And I want to know, when you draw these, are they parallel, right? Are they perpendicular or neither? So what do I have to look at here to do this? What do I need to investigate to do this? The slopes, right? I need to find the slopes of each of these lines. So I must find their slopes and then compare them, right? If the slopes are equal to each other, then they're parallel. If they're negative reciprocals, they're perpendicular, and then if they're not that, then neither. Let's just do it. So how do you figure out what the slope of a line is? How do you find the slope? Solve it for y. Solve the equation for y. Okay, get that equation. Solve for y. How can I get y by itself right now? I'm not trying to find the y-intercept. I'm just trying to solve the equation for y. Get y by itself. Move 2x to the other side. So how can I move minus 2x over? Add 2x on this side, add 2x on this side. They go away here, I get y equals, and then over here I have 7 plus 2x, right? Now this I'm going to rewrite as 2x plus 7, and this is where you need to remember when we were studying lines that there was a special form for a line, y equals mx plus b. I know we talked about it. It's somewhere in your notes. If you can solve for y, then the number in front of x, right? That's your slope. The number in front of the x is your slope. So what is the slope of this line? 2. Slope of this line is 2. So I'm going to put m equals 2 for this one, all right? Okay, that's my first line. Now I need to find the slope of the other line. So I'm going to solve for y there. So take x plus 2y equals 3, negative 3. And I'm going to do the same thing. I need to get x by itself. I mean, sorry, not x by itself, y by itself. So I need to get rid of this x. So minus x here, minus x here. Goes away. We get 2y equals, and I'm going to write this in the order, you know, the x first, then the number. So the minus x, then the minus 3. Am I there? No, I need to do one more thing. I need to get rid of this 2. So I need to divide everything by 2. So if I divide by 2 here, divide by 2 here, divide by 2 here, I get y equals, because the 2's go away. Now this right here, realize that that's a negative 1 in front of that x. Right, that's a negative 1. So the slope here is negative 1/2 in front of x. And then this number in the back doesn't really matter, minus 3/2. Y'all clear on how I got the negative 1/2?
No, we do that again.
So when we have negative x and I divide it by 2, that's the same as saying negative 1 times x over 2. But that's the same as saying negative 1 over 2 times x. So you can kind of just take this x and kind of pop it off to the back. And this then becomes the number in front. Okay? So the slope of this line is what? Negative 1/2. Negative 1/2. Okay. Are these parallel? What am I checking? To be parallel, these slopes have to be what? The same. They're not the same, right? So it's not parallel. Are they perpendicular? Yes. Why? It's the opposite reciprocal. So remember, this number right here is really like 2 over 1, right? To be perpendicular, you have to flip it over and change the sign. So if you flip it, it becomes 1/2, and you change it to negative, it becomes this, right? Or you could do this one. You could flip this one over, which would become 2 over 1, and then change the sign. What's negative, negative? Plus, right? Which is this. So you can look at it, either take that one and flip it and change the sign, or you can take this one and flip it and change the sign. But perpendicular? Yeah?
Yes.
What if this had been positive 1/2? What would your answer be? Neither. Okay? All right, any questions there? All right, I have a couple of other questions for you. This is just coming from the review. This is a new problem, all right? If I gave you this equation of a line, right? That's a line? What's the slope of that line? 5 over 4. What would be the slope of a line that would be parallel to that? No, parallel. Parallel. 5 over 4, right? Okay, perpendicular? Negative 4 over 5. Yeah? Okay, that's in your review. I gave you a line. I say, what would be the slope of a line that would be parallel to this? Well, 5 over 4. How about the slope of a line that would be perpendicular? Negative 4 over 5. So if someone wanted me to give you an example of a line that would be perpendicular to this, I could say, I don't know, let's just make up a number out here. These two lines are perpendicular, right? If someone wanted me to give a line that's parallel, then I could just use that slope. But I would want to change this number. Let's say -4. See, these two lines are parallel, right? These two lines are perpendicular. With me? I think that's pretty straightforward, yeah? Just flip and change sign. Let's move on. Quadratic functions, unless there's a question. Do you think you can handle that on a test? I give you a line, I ask you to graph it? Yeah? I give you two lines, ask you if they're parallel or perpendicular in either? Okay. Quadratics now. So for quadratics, this is where things start getting pretty bumpy. So the instructions here are to sketch this, right? So I'm going to give you a quadratic function. And y'all wanted me to give you a hard one on the test, right?
No.
Is that what y'all said?
No.
I thought that's what you all said.
No.
For some reason, my memory is failing me here. I thought y'all said try and come up with like a really, really hard one for you. Okay, I don't know. Maybe it's just not happening for me. All right, this is a very basic one right here. So let's just do this one to get started. We'll do one more after this, right? A harder one. Now on the test, I'm not going to try and give you like the hardest quadratic I can come up with, right? But I am going to test you a little bit, all right? Oh, you know what? I didn't mention what you can have, but I think I had already told you in the past. You can have another reference sheet, right? Just like you did on the first test. So you can, and I also told you on the first test to save yours, right? To save it. No? Yeah. The one that you had for the first test? If you kept it, you can actually bring that one as well. Even though it probably doesn't pertain to this at all, you can use that one as well. But you can create a new sheet, 8.5 by 11 inch standard sheet of paper, front and back. You can put anything you want on here other than worked out problems, right? You can't just work a bunch of examples. But all like the steps, like reciprocal, negative reciprocal, or opposite reciprocal is perpendicular. All these little things that you might need to help you, put it on there, all right? Okay, sketching. This, you definitely want to have the steps for this. So I gave you the steps. Anyone remember the first step for sketching that is a quadratic function, right?
Yeah.
Okay, so what's the first step?
Does it open up or down?
Does it open up or down? So what do you look at to determine if it opens up or down? Hold on. The leading coefficient, this right here, the A, right? So look, don't confuse this with polynomials. Polynomials is the one where we were like, does it do this, right? This is not. This is a different set of steps. The first step is, we know it's a parabola, so we know it either goes like that or like this. And the A determines that. For us, A is 1. Which is positive and means this parabola opens up, right, like that. I should also point out here, just so we have it, A is 1, B is -4, and C is -5, isn't it? We will need that. We will need that perhaps. We will need it. Okay, so it opens up. That's the first step. Second step. Vertex, right? Vertex. And to get the vertex, remember the vertex is either the highest point on the parabola or the lowest. In this case, it would be the lowest because it opens up, right? So it has the lowest point. That's called the vertex. We need to be able to find it, and to find it, we have a formula, right, that I gave you. You have to calculate this thing that we called h, and the formula for that was -b divided by 2a. I'm moving fast because this is a review day, so I'm trying to get through as much as I can. We've done all this. What is -b? What's the opposite of b? +4. And then 2 times a is 1. So this just comes out to be 2. Don't lose sight of what we're doing here. We're saying this point right here, right, has an x and a y coordinate. We are saying right now that this point is 2, right? We're trying to now find the y coordinate of that point, and to do that, we find this thing called k, which is what we get when we take that 2 and plug it into our function. So we want to take the answer we just got, plug it into the function, see what happens. 2 squared minus 4 times 2 minus 5. Just be careful there. When you square this, order of operations, that happens first. You square the 2, it becomes 4. When you multiply that together, you get minus 8 minus 5. I believe we get negative 9. Should be negative 9. So that means right here, the y coordinate is negative 9. Remember, on this test, I want to see the steps. I know some of y'all have graphing calculators. I'm not looking to see, this isn't like, I know in high school they just tell you to go to your calculator and graph this stuff. That's not what I'm looking for. I'm looking to see that you know how to graph this using these steps, all right? You can use your graphic calculator to check your answer, but you can't just give me a picture from your screen. I think some people on the homework, like I gave you all some homework over this, some take-home stuff, and some people actually like literally just like drew what their calculator gave them, and then with no other work. So do this. This is what I'm interested in. All right. So we've got the vertex, yes?
Yes.
2, negative 9. Third step.
Quick sketch.
Quick sketch. Quick sketch. So what we're going to do is we're just going to draw a quick little picture of what we have, starting with the vertex. The vertex is at 2, negative 9, sorry, which means I go to the right 2, down 9. So somewhere down here I have a vertex, right? And then my parabola opens up, doesn't it, from there? And the reason why we do that sketch is to see how many x-intercepts we have. And you can see here we have 2 of them, right? And so now we have to go find them. That's going to be step 4. So this just tells me I have 2 x-intercepts. And hey, just so you know, on the test, it will have 2 x-intercepts, all right, as well. I'm not going to give you like a case where it only has 1. It's going to have 2. All right, so now the x-intercepts. And this is where we have to figure out how are we going to do this. How do we find the x-intercepts? Set the function equal to 0. And the function we're talking about is x squared minus 4x minus 5 equals 0. And when we originally covered this section, right? When we originally covered this section, we had not talked about synthetic division. And you know how later, when we talked about synthetic, it actually gave us a way of factoring something? Yeah. When we were here, we didn't have that, so how did we solve this? We used that quadratic formula, right? The quadratic formula that I gave you? Feel free to use your quadratic formula. But now that you know synthetic as well, you could do synthetic to factor this. So what do y'all want me to do? Do you want me to do quadratic formula, or you want me to do synthetic? Or the good old-fashioned, yeah, if you know how to factor it, factor it. So what do y'all want, quadratic or synthetic? Please raise your hand. What do y'all want?
Synthetic.
You want synthetic? Let's do synthetic. Okay, the synthetic should work pretty quick. All we're going to do here, just keep in mind what we're trying to do. Look, if you don't want to do synthetic, do quadratic formula. I think I gave you all enough practice with that, hopefully, that you can do it. Just be aware, you know that you can make mistakes with signs there, right? So to do synthetic on this, what I'm going to do is first make a list, and I'm going to look at all the factors of 5. And fortunately for us, there's only 4 numbers to look at, right? 1 and 5. That's the only way you can multiply and get 5. And then this is where I do this upside down box. And what are the numbers that go in here? 1 minus 4 minus 5. And then I told you start with 1, right? Start with 1, try it, and then do negative 1. If that doesn't work, do 5. Let me start with 1. Okay, who wants to volunteer to talk me through how this is done? Go ahead. Okay, so what am I going to do first?
You bring the 1 down.
Bring the 1 down. Now what?
Then you multiply the
1 times 1, and put that answer where?
You put it underneath 4.
Okay, so 1 here, and now what?
You add.
Add down.
You add down, and you'll get negative 3.
3, good, and then?
You multiply the 1 with the negative 3.
And that gives me?
Bring it under the negative 5, which is not correct.
Is negative 8, which doesn't work, right? Okay, that sucks. Okay, we go again. So this time I'm going to use 1, -4, -5, and now I'm going to put, what, -1?
Yeah,
-1 doesn't either?
I think it does.
-1 I think might work, right?
Yeah.
Let's see, 1 comes down,
-1.
-1 goes underneath, add down, -5, right? -5, right? Because you're adding these. And then negative times negative times negative is positive. That goes here, and then, hey, it worked, right? It worked. Now, because that worked, this tells me. Do you want to move?
No, yeah.
You're always so like you have like the worst glare in the class.
There's a glare.
Why don't you come sit over here?
Thank you.
I know for a fact that chair is going to be open now. So,
okay.
yes.
I'll just sit there. Is that okay?
Yeah. Okay, so this is, what does this number tell us? That we have a factor of what? X plus 1, and then this is that part, right, where we have these two numbers. So it'll be x minus 5. X minus 5. So this is the number by itself. This is the number in front of x. Okay? So we have factored it, right? We have factored it. So I come back over here. This is x minus 5, x plus 1. Doesn't matter what order you put those in. Okay, notice I switched the order. It doesn't matter. Okay? And now I set each of those equal to 0. So when I set x minus 5 equal to 0, I get an answer. And when I set x plus 1 equal to 0, I get another answer, right? So here we get positive 5, and here we get negative 1. All right, any questions there? We are not doing that thing with multiplicities and bouncing and crossing. That's next. Quadratics, this is what we do for quadratics, all right? Okay, so we have step 4. We got step 1, it opened up. We got the vertex, we did a quick sketch, we had 2 x-intercepts, we found them. Now what?
We sketch it.
We sketch it. We have everything we need to draw it now. We should have everything we need. So let's draw this thing. So to draw this, I'm going to start with the very first. Well, I know it opens up, right? But I'm going to use the fact that I know that my vertex is at 2, -9. And I'm going to be a little bit more precise with my graph now. I'm going to go to the right 2, go down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9. So there's -9. So I have a point on my graph right here. That's my vertex. Look, I'm going to label it. I want an A on this test. Okay, there we go. I labeled my vertex. Now I'm going to put my what? My x-intercepts, right? I have one x-intercept at -1, put a dot. I have another x-intercept over here at 3, 4, at 5, right? I have my second x-intercept.